Before we end our introductory comments on the nature of this class, there's another phrasing that we're going to be using significantly, and that is the following. I'm going to put this in quotes, and that says, if we know displacement, and that's our variable u that we identified earlier, we know everything. And what we mean by that is, if we can figure out what u is, how much something moves, then we can get from that, and we'll see as we go through the class, then we can get the strain. From those strains, we can get the stresses. And from those stresses, then, we're going to do a mathematical operation. It's going to allow us to get the force that's going to balance the applied load. And when we do this sort of thing, we call this operation moving left to right. And when I say we, I mean I call that, so that's me, P-R-H. It's not a common mechanics statement, but we're going to be using it in this class. So displacement is key, and that's actually why in this country a lot of money is spent trying to figure out how much things move. So how much they displace, or sometimes you'll see people go directly to measuring the strain. So there are a lot of devices and a lot of experimental pieces of equipment and methods and techniques that we use to figure out how much something moves, because if we've got that, we've kind of got everything. So this is really the gold standard in a way, because if we can find out what that is at every point inside of our solid, we're really in business. Unfortunately, that's going to be a challenge for us, and it's going to be a difficulty that we can rarely do in closed form and using simple methods. But there are some where we can try that, and that's what we'll be focusing on. We're actually going to start our technical content by doing a little bit of an experiment. So what I want you to do is I want you to take whatever you're writing with. So this is going to be our first little hands-on. So experiment. And I want you to take your pencil or whatever you're using to write your notes. If you've been sitting back and you've been ignoring what I've been saying about what you should do, number one, for shame, try to repent of your bad deeds and pick up a pencil and start taking notes. But then I want you to just take that pencil or pen, whatever you're using, crayon, and if I were to ask you to break it into, so break, don't do this. I'm just saying if I were to say break into two pieces. And don't be a wise guy and say, you've got a pen with a cap and you're going to pull the cap off. That's not what I mean. I mean, you want to break it. So you want to take something that's intact and you want to break it into. Then what I want you to do right now is I want you to give it some thought if you need to, and I want you to get it into a position where you're going to do that. So don't break it, but put it under the loading that you're about to do, but don't apply the load, so just get it in position with your hand. So get in position. And if you need to think about this, I doubt you will, but I want you to stop the video, think about it, and then come back on the other side, and I'm going to predict how you're going to be loading this thing. So go ahead, and if you need to, stop the video, and then restart after you figure it out. Get it in position to break it into. All right, so now you've figured it out, and my guess is you're doing this. If this is your pencil or your pen, like so, your thumbs are here. Sorry about this. And then the rest of your fingers you've got loaded like so. So you've got your thumb, or maybe some other configuration like this, and these are the rest of your fingers, or your hands, or what have you. And you're going to bend it. And my guess is, and if we were in class together, then I would have you do this exercise as well, and I would have your classmates do it, and I can guarantee you that 100% of all of you would have it in this configuration. And this is something that is typically called 3-point bending. I'll just say 3-point bend. And it is a classic mechanics problem. The chances are you did this during your statics class. In fact, let's write it up here. Statics, it looks like this. You've got a beam that you might be pinning, and then you've got a roller here. Those are your outside finger supports, and then you're loading it somehow. I'm actually going to turn it upside down, and that would be the load that you're putting on it. And so that would be your P that you would have, and then you would have your supporting loads here. Let's say that you've managed to make this thing perfectly symmetric, so P over 2. And if you wanted to, we could draw the shear and moment diagrams. We're actually going to be reviewing that method as part of this class. But the main point that we want to pull out of this is that you are trying to break this into via bending. So the breaking is to bend it. My suspicion is nobody is taking that pencil and doing this, pulling on it. You know, you're trying with all your might. You've got it grasped between both hands and you're pulling on it. Nobody is doing that. Nobody is taking this thing and maybe twisting it. You know, I'm going to put a double arrow there for an applied torque. You've got it like so, and you're trying to break it into doing that. That's also going to be unlikely. Everybody instead is doing this. And so my question to you is why? Why did you choose to put that particular solid under that particular loading? So I want you to think about that for just a second. Once again, pause the video. This is one of the nice things about taking these classes online and having these lectures recorded, because I'm just going to keep talking basically, but if you need some time to think, just pause it, give it some thought, and then I want you to come back on the other side, and if you were sitting in front of me, then you could tell me and explain to me why you're using this particular method. And I think if we did that, if we gave it a little bit of thought, then that you would say something like experience. Now you may be saying something else. You may be saying, well, leverage, or I can get a moment, or I've done it before, or something like that. But it all boils down to experience. If you've got a spaghetti noodle and you're trying to break it into, or you've got a stick that you're trying to create a fire with outside, or you've got a candy bar and mom says break it into and give half to your little brother, and you broke it in two, but one piece is a little bit bigger than the other, and of course you give that one to your little brother, and all these years you've been racked with guilt. The guilt. Why did you do that? Why did you give them the bigger piece? But in any event, you've got this experience for snapping things, and you've realized then through all of your years on this earth that it is easiest to break something like that. And that is a perfect example of one of the sorts of solids that we're going to be loading and failing in this class. So in this case, we wanted failure. Wanted to fail the material, not the class. We wanted to fail it, and so what we did was we put it under a loading that we knew from experience was going to cause that. And what happens is, it turns out that you get higher stresses by bending something and putting it under a loading like this versus, say, something like this, pulling on it. And that is something that we're going to explore. So later on in the class, we're actually going to come back to this. So later, actually quite a bit later, it will probably be, about halfway through the class or so, we're going to come back to this. So we will be back, as Arnie might say. So we'll be back to this topic, and we're going to re-look at this particular problem and figure out why it was that we loaded it like that. So you've got already a bunch of experience to figure out how much or what it's going to take to load something so it's going to fail. You're going to load it in bending. You're going to snap that pencil or the piece of spaghetti or that guilt-ridden chocolate bar, and you're going to load it in bending. And we're going to figure out a little bit later why. All right, so now that we've got that as a little bit of background, let's go ahead and start our little discussion now. I want to rewrite what we've got. We've got displacement, which leads to strain, which leads to stress, which leads to force. So I'm going to put that as kind of a parenthetical. That is the little cloud of knowledge that's going to hover over our heads for the entire semester. And we're actually going to start here. We're going to start with stress. So we're going to label that as our first big topic, stress. Let's put a box around that for our first main topic. All right, well, we're going to take not the pen that you've been dealing with. Let's go ahead and look at just a general blob, something like so. So there is our solid. So any particular solid. It could certainly be, of course, it could certainly be our pencil if we wanted it to. But we're going to apply a bunch of different loadings to it. So let's call that F1, and I'm putting a vector on those, F2, F3, and I'm going to put a bunch of other dash lines like this. There's a whole bunch of these things. And what we're going to now do is we are going to consider some point inside the solid, and I'm going to go ahead and put it right there. And that solid is going to be labeled P. So there is a point P inside the solid, and the solid is in equilibrium. So this whole blob, and in fact, let's move this up here, and let's write down here, this is in equilibrium. And that's going to be true of all of our solids. So on every single one of our problems, we're going to assume that the statics is being satisfied. And what we want to do then is to be able to quantify the state of stress at P. So our goal is to determine the state of stress, and let's put that in quotes, the state of stress, whatever that means. In other words, we want to figure out what the stresses are at this particular point P. And to do that, the first thing that we're going to do, and this is a key, is we are going to make a cutting plane. So create a cutting plane. Now I'm going to draw it as a line, but you want to visualize it as a sheet that's slicing through. So let's draw it maybe like this, like so. There we go. So it goes right through P, and that is our cutting plane. And that's a good spot to end our second part. So we're finished now with the second